My name is Dr. Heather Williams. I'm the Vice President of Clinical Genomics Operations at Cache DNA, and I'm going to tell you about our mission to store the biomolecules of today in order to unlock the possibilities of tomorrow. We're here today because Dr. James Vanal, our co-founder, was a postdoc at MIT in Dr. Mark Batte's lab, and that forms the basis of our technology. So right now we are seeing an explosion in non-invasive medicine. You may be familiar with some of these, including non-invasive prenatal screening for pregnant women, liquid biopsy, cancer screening, minimal residual disease monitoring. All of these depend on a simple blood draw. And the collection of these samples gets everyone very excited about the possibility of leveraging the information in the genome by sequencing them. But it's difficult to say, but we're not managing this quite well behind the scenes. So I've just got some images here. When these samples are collected, they might go into a freezer farm, they could go into a basement laboratory that you see there in the upper left, or they could go into a freezer with complete disorganization. So we know that current biological storage does not scale, and we spoke to over 100 customers, and there are three common pain points. Everyone wants to keep those samples just in case. It's too expensive right now to store them, but it's also too expensive to sequence in and store that data. And because of this, the industry is mostly do-it-yourself. So we know that the way that we are storing and organizing biological samples is inefficient right now. This is only going to be exacerbated by growing healthcare challenges. Additionally, there's lots of legacy storage systems, but there is logistical challenges in accessing the samples once they've been stored. And to add on to that, although many are trying to address the lack of diversity in genomics-informed care, there is significant cost to starting biobanks to collect these samples. So what is Cache's technology? We use a biologically inspired approach. We call that caching or encapsulation. And basically that is an impermeable shell that is like a bubble around a nascent nucleic acid, whether that's DNA or RNA, that is reversible and allows easy access and storage of these samples at room temperature. So this is just a demonstration of the partnerships that we are involved in. I think many of us are familiar here with the way that cancer patients are treated in the clinic, but here you'll see that this is a patient with breast cancer. A sample of that is collected, the tumor is analyzed, and then of course nucleic acids are extracted from that primary tissue. Quite often there is a sample that is biobanked, and Cache comes in here. We are the pause. So instead of having to stick that into a freezer or ship it off to a secondary site, those nucleic acids can then be stored at ambient temperature. This allows individuals to store those samples, de-encapsulate them when they're ready to utilize them, and then analyze them in a similar way. So as the pause button, those unaltered sequences are available the same they were when they went into storage as some future state when they are retrieved. So we are supporting and seeking partnerships with commercial partners and life sciences tools companies, diagnostic labs and biobanks, and academic medical centers. Essentially anyone who is leveraging data from the storage of nucleic acids is a partner we're looking for. Thank you so much for your time.
Thank you, Heather. So how long is the cache stable for at ambient temperature?
Yeah, so we have a lot of primary data that's based on accelerated aging, which is a modality that's used to simulate time that we're at century scale. So you could theoretically put something into our chemistry and it would be available many decades later in the same form.
Okay. And how will using this technology decrease the cost of genetic tests for patients and expand precision medicine?
Yeah, so there is a lot of overhead costs in terms of infrastructure related to 24-hour monitoring of the temperature, logistics around accessing these samples. And if we can reduce those overhead costs, those monies will be freed up to offer more tests, invest in innovation, and ultimately accelerate the adoption of genomics-informed care.